In this video, we're going to move on. We're going to say, okay, we already did our sample. We already gathered our data. Now let's take that data and summarize it in some fashion. So that's what we're going to do. And for this particular video, we're going to say, how can we organize data that is qualitative? Now, the first two things we want to talk about are frequency distributions and relative frequency distributions. Now, these sound complicated, but they really are not. It sounds way more than it really is. So what is a frequency distribution? All this is a list of the values of the variable and the number of times it was recorded. So if we look down here, we're going to be working on this example at the bottom for each of these types of organizing the data. So this was like a survey of, what state were you born in? And we asked, 10 people here. So you see there's a variety of different answers. The different answers you might see are California, looks like Arizona, New York, and Nevada. These are the only states that the answers that actually exist in this data here. And if we then count up how many of each we have, so California we have 1, 2, 3, 4, 5, 6. And I just put how many there are right next to it. And then Arizona I have 1, 2, so I'll go ahead and put that there. And then New York, there's only one of them. And there's only one Nevada. So then this list here that has the different values of the variable with how many times it happens, this is just a frequency distribution. That's all it is. So it's this fancy name. We're just saying list down the different responses and how often they happen. Now you might say, well, what's a relative frequency distribution? So a relative frequency distribution is instead of listing how many times it was recorded, you list the percentage of the responses for each value of the variable. So we have the exact same values down here, California, Arizona, New York, and Nevada. Arizona, New York, and Nevada. But instead of having the specific number of them, I write down percent. Now we usually put percent as decimals in this case, but you could put it as percentages. It's up to you. So California was 6 out of 10, so 60% or 0.6. Arizona had 2 out of 10, so 20%, and then 10% each. And guess what? With that simple change, this is now a relative frequency distribution. So that's all there is to these two things here. Nothing more involved than that. Next up is the bar graph. So a bar graph lists the values of the variable on one axis and the frequency or relative frequency, whichever way you want to label it, frequency on the other axis. So in this case here, and I'm going to intentionally put them out of order. I'm going to put Arizona first, and then California, and then New York, and then Nevada. So Arizona had 2, so I'll go up, say 2 here, whatever that may be. California had 6, so it should be 3 times as large, roughly. New York and Nevada down to 1. Now, obviously, you could do a much better job, but that's the idea of a bar graph. You're just making one axis. In this case, I chose the x-axis to be the values of the variable, and the y-axis was the frequency, again, or relative frequency. And the only difference between a frequency bar graph versus a relative frequency bar graph is just based on what you label on this. If I label this as 2 and 6, then guess what? It's a frequency bar graph. If I label it as 0.2 and 0.6, it's now a relative frequency bar graph. But it's going to look like the exact same picture there. You'll notice in this part, though, I also talk about Pareto charts. And I specifically did things in a different order there because a Pareto chart is a bar graph where you put the variables, I should say values of the variable, in descending order of frequency. So in this case, you would, if you wanted to make it into a Pareto chart, you'd put the highest frequency first and then the second. In this case, the third is tied, so I know I'm running out of room here. But it's just going to look like a bar graph where it's always going down. That's going to be a Pareto chart. So again, nothing too fancy here. The last thing in that part says side-by-side bar graphs. This is, for example, let's say you get data from men and women and you want to break it down here. So you'd go ahead and say put the data for the men as a bar graph, and then you would separately go ahead and get the data for the women. And since they're having the same values of the variable, you put them right next to the other one. And then that way you can compare side by side, you know, maybe there's more men in this state, but more women from this state, and so on and so on. Now, I didn't give you a data example where we have, you know, data split up by gender, but if you did, you could go ahead and create yourself a side-by-side bar graph like that. Now, a pie chart, that's something that I think everyone's seen before. So I don't even think I need to write out in words. It's just you draw yourself some sort of a circle here, and then you're going to go ahead and create slices of your pie, and however size slice you pick, percentage-wise to the whole pie, should be corresponding to the relative frequency. So since California had 60%, you need to be a little bit more than half. So there's your California. Then you had 20% in Arizona, maybe looks something like this. And then the last part is broken up between, New York and Nevada. And again, I totally admit that my picture here is not very great, as in, the size of they're supposed to be. However, you really don't ever need to draw a pie chart by hand. We have computer software for that. But it's important to understand, if you see a pie chart, understanding what the different things mean. And these are all the main ways that we might want to organize and show off data that is qualitative. And which one you might choose for a given presentation would just depend on the type of data you have and who you're presenting it to, and which one of these just makes the most sense. And let's say you had a bunch of data and you wanted to present it to your boss. There isn't necessarily a correct way to do it. Like choosing a pie chart versus a bar graph, it's not like one of those is absolutely the correct choice in the matter. It just depends on the context. It's not that big of a deal. I would say probably the frequency or relative frequency distributions are like the lower end, just because people don't like looking at, long lists of numbers, and they like the more visual appeal of a bar graph or a pie chart. But in the end, they all are trying to say the same data, but make it in a different visual way